Okay, so let's start with question number 16. Okay, so I'll just take you through the worksheet first.
So even relative velocity was there, no? In that.
We can solve it by normal concept also without using relative velocity. Okay, I'll explain just a minute. Okay, so let's go through this question. So a basketball player standing near the basket to grab a rebound jumps this much vertically. Okay, how much does he spend in the top 15 centimeters of the jump? In the bottom 15, this should be centimeters. Okay, so basically what they mean by how much does he spend is how much time does he spend. Okay, how much time does he spend in the top 15 centimeters? So what this means is, like, if this is the ground level, okay, now suppose he starts the jump at t equal to 0 and he reaches the top position of the jump. I mean, I'm just a very rough picture. He doesn't jump so high, but I'm just saying. Okay, so this is at time capital T by 2 when his speed becomes 0. So at this point of time, he has had a displacement of 76 centimeters. Right. Now, in between, suppose this is where the displacement is 76 minus 15. So it is 61 centimeters. Okay. This is the maximum displacement. So he will reach this position once on the way up at time t1 and once on the way down at time t2. So we have to calculate the A part. We have to calculate t2 minus t1, this time interval. Okay, so is the concept clear to all of you of the 16th question? Kirti, Anirudh, you have understood now this thing?
Sir, but how much time does he spend?
Yeah, so we are calculating that. So that how much time does he spend in this thing, no? In the top 15 centimeters of the jump? That means between this position and this position, how much time he spends. So that is t2 minus t1 only, no? Understood now the language of the question?
Yes, sir. Now I got it.
Yes, sir. Yeah.
Anirudh, you also understood, no? Now, what is the easiest way of calculating this? Remember the symmetry aspect we had discussed about vertical motion. Okay. So I'm just switching to my whiteboard. So we had seen that in general, if you project an object at u at t equal to 0 from the ground, is going up and coming down. Okay, so its vertical displacement as a function of time, it looks like this, no? So at t by 2, it reaches the maximum. Let's say capital H. Okay. but at some time T1, if it crosses a certain displacement, it crosses the same displacement again T2, such that this will be the case. Okay, so there is this symmetry. Okay. So anyway, so here we know that capital H is equal to 76 centimeters. So U square by 2G is equal to 76 centimeters. That's the first thing. Okay. And if we put S equal to 61 centimeters, so 61 centimeters is equal to UT minus half GT square. So this equation's roots, the roots of this equation equals to are basically T1 and T2, and it is given, and we have to find T2 minus T1. How much time he's spending in that 15 centimeters on top. Is this clear now?
Yes, sir.
So we can just use this concept here, na, that so from here you can get the value of U is square root of 2 into 10 into 0.76. Okay, and in this equation you have 5t square minus ut plus is equal to 0. So you have sum of the roots is equal to u by 5, and product of the roots is equal to 0.61 by 5. So difference of the roots. You have done this in quadratic equations. Have you learned this concept that how you can find directly difference of the roots?
Yes, sir.
You know this concept. Okay, so
So difference of the roots, you don't know, sum and product, you know.
sum and product से difference निकाल सकते हैं, right? So from here directly you can substitute the value of u square. That is how much now? 7.6 into 2. So that is 15.2. So square root of 15.2 divided by 25 minus 2.44, right? Divided by 5. So this is going to be this time that he spends in the top 15 centimeters. Understood, no? Okay, this is clear.
Yes, but sir, can you explain the step in which you calculated this difference of the roots?
The difference of the roots. Okay, I'll explain. See, in any quadratic equation, like let's say we have ax square plus bx plus c is equal to 0. So roots, suppose the roots are alpha and beta. Okay, so we know that alpha plus beta is how much now?
Minus b by a.
Minus b by a, and we know alpha into beta is c by a. Okay,
So
so alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. So I know.
Yes, I
So
understand.
difference of the roots whole square. No? This is a trick you can use from. Okay. So actually there is a formula like this also. Difference of the roots comes out to be square root of b square minus 4ac divided by a square. Right. So it is square root of discriminant divided by a. Like you can also think of it like a formula like this. This is like magnitude of alpha minus beta. You don't know which one is larger, right? So there's another property of like a quadratic equation. Okay. And this you can understand this way also, no? That alpha is like, minus b plus square root of discriminant by 2a, and beta is minus b minus square root of discriminant by 2a. So obviously alpha minus beta. Another way to understand is this one. Subtract these two. Anyhow, so hope this is clear. So this is the A part of the question. Now similarly in the B part, what you have to do is you have to find the amount of time it spends in the bottom delta t in the bottom 15 centimeters. Now this is slightly different over here. What is happening is like if it goes up and comes down. Now let's say at some time t prime, it is here. And then again on the way down at some time t double prime, it is here. So now we have to find how much time it spends in the bottom 15 centimeters. So this will be actually t prime plus capital T minus t double prime. This will be the time it spends in the bottom 15 centimeters. Okay. So that will be actually 2 times t prime only, because these times are symmetric, right? So for this
Yes.
now you have to, for t prime, you have to find 15
Okay.
centimeters ut minus half gt square. Okay. So the roots of this one only are t prime and t double prime. So just find out the smaller root of the two here and double it. That will give you the time it spends in the bottom 15 centimeters. So this will show you that the time it spends in the top 15 centimeters is longer than the time it spends in the bottom 15 centimeters. And that gives you that visual thing that when a person jumps up very high, they seem to kind of hang at the top, because as they are reaching the top, the speed becomes slower. So they spend more time near the top compared to near the ground. Okay, is the question clear? The language of the question also, people?
So can you explain the B part also?
See, B part में क्या करना है ना? We have to find that in the total journey from ground to up 76 centimeters and back, how much of the time you are spending in the bottom 15 centimeters. You understanding? No? So you're starting from the ground at t equal to 0. Now you're reaching all the way to a height of 76 centimeters when the velocity becomes 0. But in between, you're reaching a height of 15 centimeters at some point of time. Okay, so let's say that time is t prime. And then on the way down also, you're reaching the same position at some time t double prime. And then you're finally going and hitting the ground at capital T. Okay, this is clear, this concept?
Yes, sir.
Okay, now if I ask you how much time you're spending in the bottom 15 centimeters, that is the time from 0 to t prime, and then again later from t double prime to capital T.
Yes, sir.
That is a total time you're spending na, at a distance which is between 0 and 15 centimeters from the ground.
Yes, sir.
Okay, so this is the time that you're spending, the total amount of time that you're spending in the bottom 15 centimeters. Is the sum of t prime plus capital T minus t prime. Now again from symmetry, you know that this interval of time will be equal to this interval. Because your displacement versus time graph is like this now. So if this is 76 centimeters, then somewhere here this is 15 centimeters. Okay. So this time is your t prime, this time is your t double prime. So the sum of this plus this we have to calculate, this interval plus this interval. No? Now this interval, capital T minus t double prime, is symmetric to this interval, no? 0 to t prime. So that's why this will just become double of this.
Okay.
Clear? And so that's a trick you can answer.
So,
Yes.
certainly have you given us the notes for motion under gravity and vertical motion?
I've not sent the notes. Yeah, okay, I'll send it to you.
Sir,
Okay, I'll
I
send it.
think that's not been taught.
Sorry,
I think you have not done it in the class.
So it has not been taught yet.
vertical motion under gravity we haven't done. Just a
Oh.
second. Okay, so we'll discuss that in detail today. Okay, it's basically an application of. Just give me a moment, there, sir. I'll first share the file. Do you people have your regular school lecture today?
Yes, it's 9:50 a.m.
Sorry, what time is it?
9:50 a.m.
9:50. Okay. Okay. So first of all, I'm just sending you the notes. For kinematics second session. Okay, but this 16th question you have understood. No?
Yes, sir, sir, can you show the whole question once?
The question
The
or
A
the
part,
solution?
the A part.
Okay. Okay. Okay, right. So in the second lecture, no, we had discussed about the graphs and application examples of motion with uniform acceleration. So in continuation of that only, no, we will learn about vertical motion today. Okay, so it's the same kind of situation, only we have to substitute the value of acceleration as acceleration due to gravity, right? So the same type of graphs like we had seen in the second case where initial velocity and acceleration are in opposite direction, that will apply over here.
Sir,
Yeah.
sir, I just checked the school timetable. Today the class at 10:30.
Okay. So we have some extra time, right? So we can continue till 10 o'clock.
Yes, sir.
Yes, sir.
Is it all right with all of you? We can continue the class till 10 o'clock.
Sure, sir.
Okay. Okay. So let's. So I'm first discussing some of these questions and doubts, and then I will come back to vertical motion. Okay. So next we will do 24th question. Okay, so let's come to the 24th question. Okay, so this one it says that a point traversed half the distance with a velocity v naught, the remaining part of the distance is covered with a velocity v1 for half of the time and v2 for the other half of the time. Find the mean velocity. Okay. So is the language of the question clear first of all?
Yes,
Yes,
sir.
sir.
It's not even necessary that the motion is straight line because you're talking about distance. Okay, but they're talking about velocity. Okay, so actually just change it to displacement, okay, from distance, because if you're talking about velocity, it should be in terms of displacement. Okay, so let's understand this question. So how do we calculate average velocity? What is the general formula for it? Total displacement upon total time, mean velocity or average velocity, right?
Yes.
Okay, so we have to calculate the average velocity for the entire journey. So that is equal to total displacement divided by total time. Okay. Now what is happening if the total displacement, suppose that is equal to s, then from s equal to 0 to s equal to, let's say it's s naught or whatever, s naught by 2, it is traveling with a velocity of, given to us is v naught.
V1.
Okay. A point travels half the distance को displacement बना दो, okay, with a velocity of v naught. Okay. So how much time it covered for this part? It would be s naught by
Not by V naught.
yeah, no, half the total displacement. No?
Yes, sir. S not by 2 V naught.
Okay, so it traveled from this to this at this much velocity. Okay, now what it's saying is that the remaining part of the distance was covered with a velocity v1 for the first half time and v2 for the other half of time. Okay, so now let us say the total time, suppose that is equal to t naught. Okay, so this is like a for the first part of the journey. Okay. First part of the journey from 0 to s naught by 2, it's traveling with a uniform velocity. So this is a time. Okay. So how much time is now remaining? Time remaining is t naught minus delta t1, total time minus the time that is gone. So of this remaining time, half is covered at v1, okay, and second half at v2. Okay. So what is the displacement that he's covering at v1? So second part of the journey is for time delta t2, let's say, which is t naught minus delta t1 by 2, okay, at velocity v1. So how much displacement this he'll cover?
So V1 into T naught into the T2.
So this is like an S2. Okay. And similarly, third part,
So total time is you're taking as T naught, right?
yeah, total time we've taken as TK. So delta T3 is equal to delta T2, but at velocity V3. Okay. So now we have a formula for the average velocity. It will be S naught divided by delta T1 plus delta T2 plus delta T3, right?
Yes.
You have to express it in such a way that we get the answers only in terms of V0, V1, and V2. You understanding? No? So delta T1 We have written as what? We have written it as S naught divided by 2V0. Okay. Now delta T2 similarly is, now we'll have to eliminate in this way. Delta T2 is total time. Okay, so let's understand it this way. So basically, we have to manipulate the variables here in such a way that we are able to eliminate. So the first interval, the displacement is S naught by 2, the velocity is this one. So this is the time. So the second part, what is the time? The time interval is equal to T naught minus this. Okay. And what is the displacement? It is equal to V1. So we can also do it this way, that so we can express the average velocity as total displacement upon total time. Okay, now total displacement we can write as displacement in interval 1 plus displacement in interval 2 divided by displacement in interval 3 divided by T naught. This will probably be easier. So what is the displacement which is happening in interval 1? It is S naught by 2.
Yes, sir.
So this is S naught by 2 plus the displacement that is happening in the second interval is
So I think we have
this,
to substitute everything and take out the common part like V1 common.
yeah, that's fine, but like we have to decide actually whether to substitute everything in terms of S naught or in terms of V naught. You understand, no? So that some cancellation happens in the end.
Yes, sir.
Okay. Okay. So let's try this again. So what we are having is, let's divide the journey into the three parts. First part, second part, third part. So the displacement in the first part is S naught by 2, and the time is this. Okay. The displacement in the second part we have to calculate, but the time is this. Because V2, or what was it, V1 into delta T2, V2 into delta T3, and delta T3 is equal to delta T. Oh, okay, just like this. Okay, now we have to calculate V average, which is S naught by T naught. Okay. So there are three ways we can do this, two ways. We can calculate it as okay, or we can calculate it as S1 plus S2 plus S3 divided by T naught and then substitute. Okay, so which is going to be easier here? This is what we have to understand. So if we go with this method, we have delta T1 in terms of S naught already. Now we have to calculate this delta T2 in terms of this. So this delta T2 equal to delta T3 is total time minus S naught by 2 V naught, half of this. Now V average is equal to S naught upon this thing. So this delta T2 plus delta T3,
It will become double of that.
just become this. Okay. So we have this so far, S naught by 2 V naught plus T naught minus S naught by 2 V naught. Okay. Now this T naught itself is okay. Now we have to generate one more equation, and the other equation that we have to generate is that if you see that total of these two displacements, it should be S naught by 2.
Yes.
Okay, so there we are now. So this is going to be V1 plus V2 into this time. So then basically it is, V1 into delta T2 plus V2 into delta T3. So that's our second equation. So V1 into delta T2 plus V2 into delta T3. This is S naught by 2. But delta T2 is equal to delta T3. So we have this other relation. And this time interval is this half of T naught minus S naught by 2. So this is S naught by 2. So this is clear now?
Yes.
So now we have this, see, this half and half cancels. So this T naught minus 2 S naught by V naught itself is how much? It is S naught upon V1 plus V2. Clear now?
Yes, sir.
So we substitute this here. So our V average is becoming S naught upon S naught by 2 V naught plus S naught upon V1 plus V2. So it becomes 1 upon 1 by 2 V naught plus 1 upon V1 plus V2. So when we solve this out, it is 2 V naught into V1 plus V2 in the numerator divided by the sum of all this in the denominator. This is our average velocity. Okay. So I mean, this is like, just a bit of manipulation. So this was question 24 now. Is this clear, people?
Yes, sir.
Okay, so I'm coming to the next doubt now. Again, it is a common doubt for Kirti and Anirudh. So that's good. Question number 34. Okay. So a sprinter reaches top speed excuse me, in T seconds from rest with essentially constant acceleration. Okay. He maintains the speeds and covers the 100-meter distance in 10.5 seconds. Find the acceleration. Okay. So this type of question, you just visualize what is the velocity versus time graph looking like. The sprinter is starting from rest with uniform acceleration, okay, and reaches this top speed in T seconds. So it is some t seconds that we don't know, but we know that it reaches the top speed of 10.6 meters per second. And thereafter is going for constant this thing. If he maintains a constant speed, okay, and he reaches the destination, that is, he covers the 100-meter displacement in a total time of 10.5 seconds. So now we know that the total distance in 0 to 10.5 seconds, that is how much? That is 100 meters. So from this we have to find the acceleration, this part, and we have to find the time t. Okay. So now what is the easiest method? Use the graph that this total area should be equal to how much? Should be equal to total displacement. So its area of this triangle, which will be half into base into height, plus the area of this rectangle here, which will be how much? It will be the one side, which is 10.6, into the other side, which is 10.5 minus t. So this should be equal to 100 meters. So 5.3 t plus 10.5 into 10.6 minus 10.5, so 10.6 t should be equal to 100. So you can see that 5.3 t will be the product of these two things, 10.5 into 10.6 minus 100. So from that you'll get the value of t, and once you have t, you can see that 10.6 meters per second is equal to whatever acceleration into time. So you can get the value of t. So is it clear, both of you?
Yes, sir.
You can do this with equations also, but it will become a little lengthy. If you do with equations, you can say that, okay, 0 to t, the displacement is half at square, and the velocity it reaches is at, and that is equal to 10.6. And then t to 10.5 seconds, the displacement will be the constant velocity 10.6 into the time. Okay. And then S1 plus S2 should be equal to 100 meters. So you can solve it that way also. Okay. So here you will have to eliminate E. You will have to put this thing, this equation in this, so that you will get S1 as 10 point half into 10.6 into T. Okay. And S2 is 10.6 into that time interval, which is total time 10.5 minus t. And then you will put this S1 and S2 here, and see you will come up with the same equation that we got, this equation. So it's just easier to interpret it from the graph. Okay, people, so hope the method is clear to both of you, right?
Yes, sir.
Yes, sir.
Then I have question number 38 and 40. 38 from Kirti, 40 from Anirudh. So I'll discuss them. And then we'll move on to vertical motion. It will probably take about 20 minutes to discuss the theory concepts. Then we'll do some practice questions. So if the maximum acceleration that is tolerable for passengers in a subway train is this much, and the subway station are locked this much apart, what is the maximum speed the train can attain between the two situations, between the two stations? What is the travel time between the stations? If the subway train stops for 20-second interval at each station, what is the maximum average speed? Okay, so we'll come to C part. First, we will calculate the A part, that we have to find the maximum acceleration. Okay, that is given. Maximum acceleration is given. The displacement is 806 meters apart. So I'm just switching to my whiteboard. So it says that the maximum acceleration that the train can have is 1.34 meters per second square. Okay. And the displacement between two consecutive stations is 806 meters. So we have to find the maximum speed between two stations. So now see, basically what you have to understand is that treat it like a straight line motion between two stations. Okay. So if this is station 1, an object starts from rest over here, moving with, let's say, maximum acceleration for a certain amount of time. Okay. Let's say this time is t1, and then t1 onwards it goes at constant velocity. So 0 to t1, the acceleration is the maximum acceleration. Then t1 to t2, it's in between going with the maximum speed that it has, but acceleration equal to 0. And then it starts decelerating till it reaches station 2, and its final velocity becomes 0. So in between from t2 to here, it's having deceleration at the maximum rate. So your velocity time graph, if you have to cover this in the minimum time so that in between you have the maximum velocity, it has to look like this. So here A is plus 1.34. This part, the acceleration is minus 1.34. Okay. And in between here, you're having the maximum velocity you're going with. So this time is T1, this time is T2, and this is the total time. So now do you see some symmetry in this graph?
Yes.
This triangle and this triangle will be congruent, right? So T1 is basically equal to capital T minus T2. Okay. And the total displacement is 806. Okay. So again, it is a question of that first of all, you can see that Vmax is equal to 1.34 into whatever this time T1 is. Okay. And the total displacement is the area of this triangle. So that is half into T1 into Vmax. Okay. Plus the area of this rectangle. So that is our Vmax into T2 minus T1. Okay. Plus this last triangle is again the same thing actually as the first one. So actually we can write it first like this, but then equate the fact that T minus T2 into Vmax. Okay. Now we can use this fact over here that this is equal to this. So this becomes now this will become T minus 2T1 plus this will, so this is the total displacement. Plus this will also become half T1 Vmax. Okay. Now notice the fact that this Vmax is this much. So the total displacement, which is how much now? 806 meters, is equal to T1 into Vmax plus Vmax into total time minus 2T1. So Vmax itself is how much? 1.34 T1. So this is the equation we have so far. Now think how we will solve this, because we still have two variables, capital T and T1. So how we will solve further? Just note down up to here and think how we'll solve that further part.
So it stops for 20 seconds at each interval.
Yeah, people. So what else was given in the first part of the question? Okay. So we have to find the absolute maximum speed. Na? So in what situation you can go fastest between? Right? Maximum speed also means that the total time is minimum. You understanding my point, people?
Yes, sir.
Okay, so we want capital T should be minimum. So how we will make capital T minimum over here? By creating a situation where it does not spend any time at the constant speed. It accelerates and decelerates. So for this case, for the total time to be minimum, the graph should simply become like this. It should just become an acceleration and a deceleration. That way, this peak will reach maximum. No? You understanding? No? It's like this, imagine different versions of this graph where the area is the same. So one version is like this. This total area is whatever 806 meters. Now imagine another version where it goes accelerates for a longer time, but the total area is the same. Okay, so the total time will become less now.
Yes, sir.
So like this, when will the total time be minimum when this happens? This will be when the total time is minimum and the maximum speed is maximum. You getting my point now? So this graph has to be converted to this for minimum possible capital T. Okay. And that means maximum possible speed. Okay. So if that happens, it's very simple now. Okay. So this is becoming T by 2 and this maximum speed is just double of this area. So half of base into this height, which is 1.34 into T by 2. Double of this area has to be equal to 806. So that's it. That solves the problem for us. That gives us the value of capital T, and from capital T we know this V max. V max will be 1.34 into T by 2. Okay, so is it clear, Kirti?
Yes, sir.
So this was a tricky thing in the question. Okay, to understand that we don't want, if we want to minimize the total time taken between the two stations, then we want this flat part to actually become just an instant instead of an entire interval of time. It should just accelerate till it reaches the maximum possible speed, and from that point it should decelerate at the maximum deceleration possible, which is 1.34 meters per second square, so that it's able to maximize this area with a minimum base, and the base is the time. Okay, so that's question number 38. Let's move on to question 40, which Anirudh you have asked. So 40 is also a good question for interpretation. So reaction time for the driver is given to us. A driver having a definite reaction time is capable of stopping the car. So let's say this reaction time is some delta t, which we don't know. Okay. Now the total distance in which he can stop the car is 30 meters on seeing this thing when his speed, initial speed is 72 kilometers per hour. Convert that to meters per second for me. So it will become how much?
Wait,
Right? No,
20, right?
20 by mistake. Yeah. So this, when the initial speed is 20 meters per second, he can stop the car at a displacement of this. Okay. And over a distance of 10 meters, when the initial speed is 10 meters per second. So we have to find what is okay. So let's understand this question. So first of all, what does reaction time mean? It means that it takes some time to apply the brakes. Okay. So let's say this signal is over here and a car is coming here at an initial speed of u. This is the time t equal to 0 is the time when he decides, or you can say when he sees the red light. So what will happen is that he will continue at uniform speed for some time. Till delta t, he'll continue at uniform speed. From here to here, he has zero deceleration because his body is still reacting. Now from here onwards, he starts decelerating. Till he comes to rest. This is the meaning of reaction time. So again, if you think of your velocity time graph, look like this. So if he stops at some time capital T here, for reaction time amount of time is going at constant velocity, and then he starts decelerating till his velocity becomes 0 at this time. Okay. So in the first data that is given to you, that this total displacement, so this total displacement S is equal to It's given to us that it is 30 meters when the initial speed is 72 km/h. Then is given to you that the reaction time is, the displacement at which he stops is 10 meters if his initial speed was 36 kilometers per hour. So we have to find that what will be the distance in which he can stop if the initial speed is 54 kilometers per hour. Okay. So in each case, he has a certain maximum deceleration. We don't know. Okay. So the total distance that he covers, this graph, the total distance he covers will be u into delta t plus this part of the displacement. So for this part of the displacement, we can write it like this: from t equal to delta t when the speed is u to t equal to capital T when the speed is 0, let the deceleration equal to a. So the relation is that 0 is equal to u square minus 2 times a into whatever displacement he makes. So the displacement in the second part, delta s, is what? U square by 2a. So this you are understanding, all of you, this part? The total displacement, that is the total area, is the displacement during this reaction time plus the displacement during the time of deceleration, which is my delta s.
So the reaction time is supposed to be very small, right?
Yes, yes. So it's like, just imagine the graph is like this. It's like very small amount of time here and then decelerates.
Okay, sir.
But it's significant. No? So this box's area will be how much? Whatever the initial speed is into that reaction time. Whereas this triangle's area, we can calculate independent of time as whatever the initial speed was divided by 2a, where a is the rate of deceleration. Okay, so this is clear now?
Yes.
So from 0 till he stops, what will be the total displacement he makes? It's the sum of these two. No? So this will be the total displacement, this one. So now fit in this data here. Okay. So 30 is equal to, I've converted this to 20 delta t plus 20 square by 2a, where a is unknown. Okay. And this data is giving me that 10 is equal to 10 times the same reaction time plus u square by the same rate of deceleration. Every time he breaks, the deceleration the brakes provide him is the same. Got it, no?
Yes, sir. So we have to eliminate using
Yes. So now
simultaneous.
using this equation and this equation, you can now find the value of delta t, you can find the value of t. And for that, now you have to calculate this. So this is going to give me, I want to calculate what is the total distance. So that will give me 54 is how much? 15? Okay. So this I want to calculate. So I'll substitute this. Okay, so this is clear. You can finish the question from here, Anirudh?
Yes.
Okay.
Yes.
So just take a minute to go through this if you like. Then now we'll come to vertical motion after this.
So doubts from objective section you'll be clearing later.
Yeah, I'll discuss in the next lecture. Okay, because we'll need some time for vertical motion. Let me see. I'll try to finish vertical motion and come to those doubts. Okay.
Yes, so for the major test, we'll have relative velocity also.
No relative velocity. The major test is only up to motion along a straight line. So the portion is up to what we have discussed in the last lecture actually. Kinematics 2 lecture, na?
So vertical motion will not be coming.
See,
Will it?
vertical motion, like, vertical motion is an application of motion with uniform acceleration along a straight line. You're understanding the point now?
Yes, sir. So
So, uh, so for example, if a question says that an object is dropped from a tower which is of so much height and the value of g is given to you have to find the time taken. So we just use those standard equations. No? S is equal to ut plus half at square, v equal to u plus at. So that's part of motion in a straight line.
yes, sir. So the problems which will be coming, like they'll be similar to what you done in set one.
Yes, yes, yes. Set one is actually a little beyond what will come in the test. Okay, but yeah, you can use set one as the guideline. Okay, just basically go through the questions we have done in the last two lectures and in today's lecture also, like including vertical motion as an application. It should give you the guideline of what is coming in the major test. Okay.
Yes, sir.
Okay. So now we will see vertical motion under the action of gravity. So this is like we're treating it as a separate thing, but it's basically just a case of uniformly accelerated straight line motion. Motion in one dimension. Okay. Just a case of that. Because mind you, what we are doing here is assuming the motion is at a maximum distance from the Earth's surface which is negligible compared to the radius of the Earth. Earth's radius is approximately 6,400 kilometers. Okay. So acceleration due to gravity, what we write as small g, is uniform. Okay. If we start talking about vertical motion, where the particle is projected to thousands of kilometers, okay, or even close to about more than 700-800 kilometers from the surface of the Earth, then we cannot treat the acceleration due to gravity to be uniform because the distance from the center of the Earth is becoming so large that small g will start to decrease significantly. So here in this section, we are assuming that we are always at a maximum distance which is negligible compared to the radius of the Earth. Okay, so that we can treat small g as uniform. And small g's value exactly is 9.8 meters per second square. Approximately in most questions, you will take it as 10 meters per second square. In the exam, the question will always tell you the value of g you have to take. Okay. Or if the question doesn't, then in the question paper at the beginning, there will be a set of values of constants. There will be a table of constants. So that will include the value of g you have to take for all the questions. So typically it is 10 meters per second square, but sometimes you need to take it as 9.8 also. So now let us see the different cases of vertical motion under gravity. The first case is the simplest, free fall, okay, starting from rest. So this is a case when object is just dropped from a certain height. So why this is the simplest is because the initial velocities. So take this situation. A person just drops an object or a ball or whatever at t equal to 0 with initial velocity equal to 0. He just drops it from a height which is h above the ground. So if he drops it at t equal to 0, because of gravity, it will have a straight line path down. So at some time t equal to 0 is dropped it. It will have a velocity v and it would have covered a displacement s. And like that, this will continue. And finally, it will hit the ground with some velocity which we can call as the impact velocity at time t. So here at t equal to t, the velocity will become how much? It will become gt, and the displacement will become how much? It will become half gt square. Because what we will do here is we will take our y-axis pointing downwards. Okay. So if we take the y-axis pointing down, we will consider the acceleration of the body to be plus g, because that acceleration vector is pointing downwards and the initial velocity is 0. So now using the equations, that s is equal to ut plus half at square, b is equal to u plus at, and b square is equal to u square plus 2as, we get this equation. So this is the first equation, this is the second equation, and b is equal to square root of 2gs. This is from the third equation. Okay. So if at t equal to capital T, it hits the ground. Okay. And when it hits the ground, it has an impact velocity vi. So from equation 2, we can see that h is equal to half gt square. So the time taken to hit the ground is given by this. How much time it takes to hit the ground? That is this. Okay. Then from equation 3, you can see that the impact speed will be square root of 2gh. So don't need to memorize these two as formulae. You can just remember how they come from the equations. What you need to do is understand how we are applying this equation. The sign convention, that I am taking my axis downwards, so everything pointing down will be written with positive sign. So that is why the displacement is also plus h. Okay. When it reaches this, the displacement becomes plus h, because my axis is pointing downwards and the magnitude of the displacement is h. So just make a note of this and let's look at a simple example. So a body is dropped at t equal to 0 from a height of 20 meters above ground. We find the time taken to hit the ground, the impact speed, and also its displacement in the last 1 second before impact. The last 1 second before impact. So just note this down and try out this question. Take G as 10. Yes, anyone got the answer? Yes. Yes, correct, Anirudh. Okay, so let's work this out. So the first and second part you can do directly by formula. The impact speed is 20 meters per second. Now the third part, we need to understand that if the object is starting from here at t equal to 0 with initial velocity equal to 0 and hitting the ground at t equal to capital T, which is 2 seconds, with an impact speed of 20 meters per second, 20 meters below. Now in between where it is at t equal to 1 second, at t equal to 1 second, you can see that this displacement is half gt square. So that is 5 meters. So from here to here, how much it is traveling then? It's traveling 15 meters. So this displacement from 1 to 2 seconds is equal to 15 meters downwards. So therefore displacement in the last second, that is from t equal to t minus 1 to t equal to t. So that in this case is 1 second to 2 seconds. That is equal to 15 meters. So it travels 5 meters in the first second, 15 meters in the second second, and therefore the total displacement is 20 meters in 2 seconds. Okay, so most of you got this correct. Good. Okay, now let's go on to the second case. Vertical projection from the ground level. So what is happening at time t equal to 0? From the ground level, we project something vertically upwards at a velocity of u. Then as it moves up at some time t, let's say it's still going up, as a displacement of s. It eventually reaches some position where its velocity becomes 0 for some instant, and then it starts coming down. It exactly retraces its path and comes and hits the ground at some point of time with an impact speed like this. So here what we'll take is we'll take our axis, our y-axis, as upwards, because the initial displacement is happening in the upward direction. So we'll write the initial velocity with a positive sign, but we'll write the acceleration with a negative sign. So at some time t, v will be u minus gt, s will be ut minus half gt square, and v square will be equal to u square minus s. So from this we will see that our displacement time graph and our velocity time graph respectively will look like this. Now at this stage we are not concerned what happens after it impacts the ground, whether it bounces or it just comes to rest or whatever. So now we'll see that at t equal to capital T, the displacement is 0. So from equation 2, we can see so we have this formula. This is called the total time of flight. That is, we can understand it as ascent plus descent. Just write down up to here first, then we'll discuss more. So we'll develop the formula for the total time of ascent plus descent, which is 2u by g, and the formula for the maximum height, that is the height it reaches at the topmost point, or the displacement it reaches at the topmost point.
So so yes, so from the
Yeah.
objective axis, I was telling you there are many relative velocity problems in that. So will those type of problems be coming for the test or only after this tutorial will it come?
In what better relative velocity questions you see?
In the objective part of the practice set 1.
Yeah, but see, you can solve them without using relative motion also. No, those type of questions will not be done.
Sorry, can you repeat?
those type of questions will not come. Relative velocity questions will not come.
Okay, so after it is taught, those type of problems will come only after it is taught. Right?
Yes.
Okay, sir.
Sir,
Yes.
so can you please confirm whether NLM is coming for the major test or not, because nothing has been started yet in that chapter.
Achha, Newton's laws of motion has not been started for you.
So constraint motion is done. Newton law of motion is not yet started.
So constraint के पहले जो है, that is also Newton's laws, ना? Like free body diagram has been discussed, ना बेटा?
No, sir.
No, sir.
Normal reaction,
No, sir.
like Newton's laws has not been discussed at all. Newton's first law, second law, net force is mass
No,
into
sir.
acceleration.
No, sir.
Okay, so
No, no.
okay. When was the last lecture you had in Hemant's track?
This Friday. This the previous week Friday.
Previous Friday. So sir has covered what in that lecture?
He covered wedge constraint.
So wedge constraint is part of Newton's laws, na beta? Wedge constraint is part of Newton's laws. Na? In wedge constraint, you have done questions where you are calculating the acceleration of different wedges, etc.
Yes, sir.
Okay, so that is part of Newton's laws. Na? Have you done things like, for example, an object sliding down an inclined plane,
No, sir.
smooth inclined plane, g sin theta hona chahiye acceleration?
No, sir.
Or have you done problems of equilibrium where an object is between two surfaces, you have to calculate contact forces?
No, sir.
Okay, how many lectures have happened after this thing, vectors?
Around 3.
Okay, so whatever is covered in those lectures, no, but only those questions based on that will come. So what all has been covered after vectors?
He covered. Pulley constraint was covered.
Okay,
That like the pulley constraint formula that velocity of pulley is equal to velocity of the two blocks by 2.
okay. But I think as far as I know, constraint relation based questions are not supposed to come in this test. It is like simple Newton's laws.
Yes, I asked Ganesh sir also about this. So he told that constraint related problems won't be coming. He only told F is equal to ma normal reaction and all those problems will be coming. But that
Okay. So you have not been taught how to calculate those type of situations. Like I'll just give you an example. Just see what I'm putting up on the board here. Let me just finish the formula for this. I'll come back to that. Huh? So this one you understood the total time kaise hai? Okay. Now the second thing is, see, when it reaches the highest point, its velocity should become what? 0. When it reaches this highest point, the velocity is instantaneously 0. So which equation we can use for maximum height? The third equation.
yes,
Okay. So when S is equal to h, that is the maximum height, at that instant, the velocity is 0. So from equation 3, we have 0 is equal to u square minus 2gh. So we have the formula that depending on how much speed we throw the object with, this is what is happening. Okay. And we also have from equation 1, v is equal to u minus gt. So in this substitute v equal to 0, you'll see that the time is equal to u by g, which you will see is half the time. So this is also an important fact that it reaches the highest point at half the total time of flight, reaches maximum height at half the total time. So the ascent and descent are symmetrical. Okay, stop shouting. So that's why you can see that reflected in the graph also. In the symmetry of the graph, you will see that the upward journey and the downward journey, the ascent and descent, are exactly symmetrical with respect to each other. It reaches the maximum height at half time, and it takes the same amount of time to come down as it is taking to go up. You people have not had any board lectures in Newton's laws also, no?
We had one.
What was covered in the board lecture?
Uh, the whole chapter was completed.
Okay,
I will understand most of the things, but
it doesn't matter. Who took the board lecture?
Ajit sir.
Ajit sir. Okay, it doesn't matter. Okay, don't worry. Nothing that you haven't been taught will come in the test. Okay, but I'll just like clarify with you people what all things you are able to do. Accordingly, we'll discuss. Okay. So anyway, these two formulae are clear, no?
Yes, sir.
Okay. So one is like in vertical motion, you can have direct type of questions that initial speed is given to you, calculate the maximum height, time, and all this. Okay. But the other is there's also a symmetry of motion. Like for the in-between part, the ascent and descent are symmetrical. So sometimes that becomes important while we are solving questions, like the questions we had discussed from the problem set earlier today. Okay. So they can always be solved. Any question can be solved from the three equations. So technically equation 1, 2, and 3 usse zyada we don't need anything else to solve. But if we notice the symmetry of the motion, it becomes easier to solve certain type of questions. Okay, so that is why I'm explaining this point separately. Symmetry of the ascent and descent part. So the symmetry of the ascent and descent part is something like this, that, okay, stop yelling. So if we are projecting something at time t equal to 0 with an initial velocity, u like this. Now on its way up, so it's going to this point here when it velocity becomes 0. So on its way up, suppose it's at some position with a velocity v1 in the upward direction at time t1. Then again it will cross that point on its way down also. So when it crosses that point, the velocity it will have now, it will be exactly minus of v1 from symmetry. And whatever time there will be, t equal to t2, that time will be such that it's symmetrical. Okay, so what will happen is that time t2 will be capital T minus t1. So basically what I'm trying to say, suppose we have a situation where we project something at, let's say, 50 meters per second. Okay, we are taking g as 10 meters per second square at time t equal to 0. So now you can easily calculate that when it reaches the highest point, u by g, so it reaches the highest point at a time of 5 seconds. And then it comes back to ground at a time of 2u by g, which is your capital T, that is 10 seconds. Okay. Now, in between, if you see, where was the particle at, let's say, 2 seconds? It would have been somewhere here, going up with some velocity v1, which I'll calculate now. Now, you can also say for sure that it will be again at this position only. At what time? If this was 0 to 2, then the time from here back to the ground should be 2 seconds. So this time t2 should be capital T minus t1. So it should be 8 seconds. And whatever the velocity v2 will be here, will be minus of v1. So now you can calculate that, for example, at t equal to 2 seconds, the displacement is equal to 50 into 2, that is ut, minus half gt square, that is 5 into 2 square. So you can see that's how much, 100 minus 20. So that is 80 meters. Okay. Whereas the maximum height, you see, is u square by 2g. So that will be 125 meters. Okay. Now you can see that at t equal to 8 seconds, okay, and at this point of time, the velocity will be u minus gt. So it will be plus 50 meters per second. Okay. You can see at 8 seconds, the displacement will again be the same because it's at the same position. See, it's 80 meters. To prove this point, that if this time is T1, then this time is T2, which is T minus T1. So it reaches the same displacement, but the velocity will become negative of that. It will be U minus GT. So it will be minus 30 meters per second. So that is the symmetry of the motion. That if on the way up it crosses a certain point, then on the way down it crosses that point at a symmetrical time and with a symmetrical velocity. That is the negative of that velocity which it had at time T1. Okay, so hope this point is clear to all of you. Now, just one more thing to be careful in an example like this is the difference between distance and displacement. So in this example, we have taken U as 50 meters per second. So from that, we have calculated maximum height is 125 meters. Total time of flight is 10 seconds. These were the standard things. And what we've also seen that at 2 seconds and 8 seconds, for example, there is this symmetry. Okay. Now, one more thing that can be asked in this type of question is distance. So if you want to find the distance traveled from 0 to 6 seconds, can you tell me how to calculate this?
So first we'll calculate from 0 to 5 seconds, which is
Yes,
125 meter. Then we'll consider the initial velocity as 0 and we'll calculate for 1 second from the top. So we'll add both
yes,
the two and we'll get that.
you can do that. Okay, so what you have to do is now when you look at the value of U, you have to first understand that when it reaches the top point. So from the value of U, you can see that it reaches the total time of flight is how much? 2U by G to 10 seconds. So it reaches the point, highest point at 5 seconds. So the moment you can see the question is asking you 0 to 6 seconds, you understand that it has gone to the maximum height and come down. So the distance will not be equal to displacement. It will be greater than displacement. Okay, so that is the point. Understood, no?
So for 5 to 6, we have to calculate separately, and 0 to 5,
Yeah.
120.
Yeah, so see, maximum height you've already calculated. So this will be this plus the displacement from 5 to 6 seconds. Okay. Now for 5 to 6 seconds, what you can do is you can use the formula of displacement only. You can calculate displacement at t equal to 6 seconds. So it will tell you where it is from the ground. Okay, that is ut minus half gt square. So see how much this is 300 minus 36 into 5. So that is how much?
180.
So that this is going to give us how much? 120. So that means that 6 seconds where it is at 120 meters from the ground. So how much it has traveled between 5 and 6 seconds? 5 meters.
Yes.
This is at t equal to 5 seconds. But now it's this formula showing you that at t equal to 6 seconds, where it is at a displacement from the starting point of how much? 120 meters. So that means how much it has traveled down during this time? It's traveled 5 meters. Okay. So this will become 125 plus 125 minus 120. So it become 130 meters. So the total distance it has traveled from 0 to this much upwards and this much downwards, but total distance is 130 meters. Okay, understood. This is clear.
Yes.
Okay, just now one more type of example we'll cover, and with that we'll finish this vertical motion part. Now suppose we have again that heighted position, okay, but this time instead of dropping an object is, in case one we are throwing it down, okay, and case two we'll actually throw it up. So given H is equal to, let us say, (300 meters). In case 1, U is equal to 20 meters per second downwards. So we have to find impact speed and time. Okay. In case 2, we are giving it again 20 meters per second, but upwards. So again, it's going to hit the ground. We also want to calculate total distance. Take G as 10. Just try out this question. From the same height of 300 meters, once we are directly throwing down an object at 20 meters per second, second time we are repeating the experiment. Instead of throwing it vertically down, I'm throwing it vertically upward. So first it goes up and then comes down, and we allow it to fall to the ground, which is 300 meters below. Yes, very good. That's correct, Anirudh. You are sure your school lecture is only 10:30, na? Not before that?
Yes, sir.
It's at 10:40.
Okay, so why so many people have left the class? Anyway. Yes, very good. Impact speed is correct. Very good. Kirti, correct. Very good. Correct. Okay. So what you can do is not to solve the first part for the rest of you also. For the first case, when you throw the object downwards at t equal to 0, you can take your y-axis downwards. So you'll take your initial velocity with a plus sign. You take your acceleration also with a plus sign. Okay. And when it hits the ground below at t equal to capital T, your displacement should be plus 300 meters. Okay. So 300 should be equal to 20t plus 5t square. So we solve this for time. Okay. So we get t as, can't take this, we'll take this. Sorry, other way around. This is the solution. Negative time cannot be possible. So the time of hitting the ground is 6 seconds. And you use v square is equal to u square plus 2a into s. So from this you will see that the impact speed will come out to be 80 meters per second. Alternatively, there's one more thing you can do. What you can do is you can solve this thing first, and then you can use the fact that v impact is equal to u plus g2. So from that you can find the time. So 80 is equal to 20 plus 10 into capital T. That way you don't have to solve a quadratic equation. You can see solve it this way also. Yes, very good. For the second case, you will see that the total time will become 10 seconds. That's correct. Very good. And the total distance will be 20 plus 20 plus 300. So 240. So second case, what you do is, since you are throwing the object up, okay, you can take the upward direction as your axis. Take y-axis upwards. So you take u as plus 20, acceleration as minus 10 meters per second square. So at t equal to capital T, your displacement should be minus 300 meters because it's 300 meters below. Okay. So minus 300 is equal to 20t minus 5t square. So I have this equation, t square minus 4t minus 60 is equal to 0. So your roots of this equation will become 10 and minus 6. Okay. So this is, so the total time will be 10 seconds. Okay. Then your V impact square is equal to U square plus 2 into A into S. So but with proper sign, actually you should write it as minus 80 meters per second. This is downwards. Okay. And now what we can do is you can find this height from here to here. You can find this height because at the top point V is 0. So this height will be how much? It will be U square by 2G. So it will be 20 meters. So you can see that the total distance will be 20 up plus 20 down plus 300 downwards. So 340 meters. So total distance will be 20 plus 20 plus 300. That is 340 meters. Okay, so these are the different kind of situations in which you have to solve vertical motion. Every time the equations are this. So just about the test on Sunday from kinematics. Okay, make sure you're clear with all the one-dimensional parameters. What we learned in the first lecture, the relationship between V and S. dV by dt is acceleration. Integration of velocity is displacement. ds by dt is velocity, and integration of velocity is displacement, like that. Those kind of things. Okay. Variable acceleration, constant acceleration, whatever. Then the special case of uniform acceleration and the use of the three equations. What we've been doing in the last lecture and today's lecture, second and third lecture, that is very important. Okay. And those type of questions that we discussed, average velocity, instantaneous velocity in an interval and all that. Okay. Now I just need 2 minutes of your time to understand what all things you can do in Newton's laws. So for example, if I give you a situation like this, okay, that we have, let's say, a cylindrical object which is between two inclined planes at rest. This angle is 30 degrees. Let's say this angle is 30 degrees. And this has a mass of something like, let's say, 2 kgs. Can you find the normal reaction force? Have you done questions of this type?
No,
The
sir.
normal reaction has not been done.
Yes.
Achha, normal reaction is not been done. Okay. And what about if I give you a question of this type, that you have a smooth horizontal surface? And on that, I've kept some block of some mass, say 10 kg. This is smooth. And now I start pulling it with some external force of, let's say, 15 newtons at an angle of some theta, let's say 37 degrees with the horizontal. Then can you find the acceleration of the block?
Yes, sir.
This type of question you can do?
Yes, sir.
Yes, sir. Yeah.
So what we will apply in this question is that net force is equal to mass into acceleration. right? So you see that on this body, how many forces are actually acting? There is weight, right? There is this external force that we are applying, and the ground is pushing it upwards with some force that is called normal contact force. So even though you haven't studied that yet, so you will see that now what we have to do next, we have to resolve the forces because the acceleration is happening in the horizontal direction. So we will take the horizontal direction as our x-axis, the vertical direction as our y-axis, and we will resolve this force. So we'll convert this to x component of the force. That will become how much? F cos theta. So 50 into cos 37 is how much? 40 newtons. Okay. F's vertical component, which in this
30.
case 30. Okay. Normal reaction that the ground is applying, which we don't know, and the weight of the object mg, which is given to us as 50 newtons, taking g as 10. Now under the action of this, it should have a horizontal acceleration E. So when I resolve Newton's second law in component form, along y-axis, what is happening? The acceleration is 0. So net force should be 0. So the forces should balance. So Fy plus N should be equal to mg. Okay, so that will tell me how much my normal reaction is. So that means the ground is applying how much normal reaction force on this? Only 20 newtons. Whereas if that external force F was not there, then the normal contact force would have been 50 newtons. It would have been equal to the weight. And along the x-axis, our acceleration is how much? A, which we have to find out. So net force is how much? Fx. So that has to be equal to ma. There's no other force. So F cos theta in this case has to be ma. So 40 newtons is equal to the mass, which is 10. Oh, sorry, the mass is 10. So the weight should be 100. My mistake. Not 5. So the weight is 100 newtons. So normal reaction in this case will be 70 newtons. Okay. So this is 100 newtons. So
So
anyways, yeah.
Sir, I
So
think
that's,
I've done these kind of problems. Class,
sorry.
in the
Yeah.
class, I have not done these kind of problems.
This type of question you haven't done. Okay.
No,
Okay.
sir.
So okay, then the questions will be modified for your test in such a way that what we have covered in the class, that only that part will come in the class. Okay.
okay, sir.
Okay, sir.
Okay. You have some doubt session also, na, in physics coming up this week.
Yes, sir. Thursday evening, 7:30, 8:30.
Okay. Who is taking that doubt session? Sir has announced.
No, sir.
No.
Okay. So we'll see. Maybe some part of this will be covered in that also. I don't know, but depends on who takes the session. But don't worry, like the test will be based on questions that we've done in class, the type of questions you've done in class. Okay. So for kinematics, just cover the lecture notes of the 3 lectures that we've had so far, lecture 1, 2, and 3, and also go through the problems that we discussed from the worksheet today. Those type of questions can come, because that's nothing to do with relative motion and all. It's all straight line motion with standard formula. So that's it for today's session, people. Thanks for attending. Sorry for delaying the lecture to so late, but okay.
Sir, so relative motion kind of problems like those in the worksheet won't be included.
No, relative motion won't be included. Okay.
Okay, sir. Thank you, sir.
Okay.
Sir, and normal reaction means the force exerted by the ground perpendicular to the object, right?
Yes, see, normal reaction, the term reaction has to do with like reaction force. Like when object, or we can say that when 2 surfaces are in contact, they react to each other by pressing each other. So, and that direction of that pressing force is always perpendicular to the surface. So that's why it is called normal, because the word normal in geometry means perpendicular. So it's a perpendicular reaction force. That is normal reaction.
Okay, sir.
So it's like a pressure into area, but the direction of it is perpendicular to the surface. So that is normal reaction force actually.
Okay, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay, people. That's it for today. Wish you all the best.
Thank you, sir.
If you have any last moment doubts, you can always send me on WhatsApp also. Okay.
Yes, sir.
Okay, sir.